Alright, so we're looking at solving rational equations today. So again, you've gone through the lesson, just a quick overview. So there's different strategies, there's a lot of different ways you can solve problems depending on what they throw at us. But I'm going to focus on one strategy today that involves cross-multiplying, because I think most students are pretty comfortable with that. So when you solve these types of equations, here's a big thing. Make sure you plug your answer back into the original equation to see if it works. Okay, we can generate what we call extraneous solutions when we solve these sometimes. They might not work, so we just need to check them. Okay, so let's look at a little example here. And so I've got a little equation. Solve x over 6 equals 5 over x plus 1. Well, hey, we can cross multiply, right? So let's multiply x times x plus 1 and 6 times 5. So here's what I'm doing. Right? And this is a pretty familiar strategy for you. So that would give us x times x plus 1 equals 6 times 5. So x squared plus x equals 30. Oh, we've got a quadratic. Okay, so x squared plus x minus 30 equals 0. Set that equal to 0 and then solve it. This one's going to factor for us. And so we've got x plus 6 times x minus 5 equals 0. So x could be negative 6 or x could be 5. Okay? So it looks like there's two solutions. Well, let's see if those work. Okay, we just need to go back and check. So negative 6. So negative 6 over 6 would be negative 1. If I put a negative 6 in here, I get negative 6 plus 5. That'd be negative 5. 5 over negative 5. Hey, that's negative 1. That would be true. What if we put 5 in here? So 5 over 6 would be 5/6. 5 over 5 plus 1 would be 6. 5/6. So it looks like both of those work. Both would be valid in this situation. Okay, let's go look at another example. Just a slightly different situation. What if we've got multiple expressions on one side? Okay, I can't just cross multiply directly. So again, there's different strategies, but here's what I'm going to encourage you to do, because I think it makes sense to, again, most students starting out solving problems like this. Let's combine this side into a single expression, and then we can cross multiply, which we're comfortable with. Okay, so let's get a common denominator over here. It's going to be 6. And so x over 6 is fine. I need to multiply this one by 2 over 2. And so let me rewrite. So I've got 5 over 6x equals x plus 4x over 6. Can you see what I just did? So I just combined this side right here into a single fraction. Hey, now I can cross multiply. So 6 times 5 is 30. 6x, let's multiply it up through this. So I would get 6x squared plus 24x squared. Is that right? 24x squared, yeah. Okay, so now let's see what we'd get. So I have 30 equals 30x squared. Of course, you can divide 30 by both sides. I'm kind of jumping over here just to give myself room. X squared equals 1. Hey, square root both sides. X could be plus or minus 1. And if you go plug them in here, those are both going to work. Okay, you can go check yourself. Okay, another thing that rational equations can help us do is solve rate problems. So rate is just how quickly something's happening. Whether it's a speed, you're traveling, it's how quickly work's being done, we're filling a tank, we're selling tickets. There's all kinds of things that involve rate, okay? So these can involve any kind of situation that involves rate. Again, I just mentioned a few. A table can help us identify what we know, what we're trying to find. Let me go illustrate with a couple examples. And these will be pretty typical, the type of things that they're going to want you to try. After school, Marcus can walk 1 mile to the library, okay? About the same time, he can bicycle 2.5 miles to the store. His speed on the bicycle is 6 miles per hour faster than his walking speed. What's his speed? Okay, and here's another key. About the same time. And they've given us a table. Let's plug things in. What's the distance to the library? Well, it's 1 mile. What's the distance to the store? 2.5 miles. So 2.5. What's the rate? How quickly is he walking? Well, we don't know, right? That's what we're trying to figure out. So we're just going to call that R. What's the rate he's riding? Now, here's where this comes in. His speed on the bicycle is 6 faster than walking. So this would become R plus 6. What's his time? Well, we don't know. But here's what we do know. It's exactly the same for each one, okay? So if I use this equation, distance equals speed times time, and I rearrange it, time equals distance over speed. Well, I know this time and this time are the same, so I'm going to basically create two equations. So distance over speed for the library would be 1 over R, and that equals distance over speed for the store, which is 2.5 over R plus 6. Notice how we just created a little problem where we can cross multiply and solve. So let's cross multiply. So 1 times R plus 6 is R plus 6 equals 2.5R. Let's subtract R over. So 6 equals 1.5R. And let's divide that 1.5. Hey, R equals 4 hours, it looks like. Or I'm sorry, we're not doing hours. Miles per hour. Okay, we're finding a rate. So he's walking about 4 miles per hour is what we just calculated. Okay, let's go try one more, slightly different situation. Roland and Sam wash dogs to make extra money. That sounds exciting. Roland can wash dogs in 4 hours, how many ever dogs there are. Sam can wash them all in 3 hours. Well, what if they get together and they wash them? How long is it going to take? This is a typical work problem. Well, Roland is 4 hours. Sam is 3. Combined, we don't know, right? That's what we're trying to figure out. So how many dogs per hour does he do? Well, he does 1/4 per hour of all the dogs, because it takes him 4 hours. Sam does 1/3, and combined, okay, is what we want to figure out. And so we're going to create an equation here. So basically, what this rate is, the time here would be t, and this would be 1 over t. So 1/4 plus 1/3 equals the combined. Okay, and we could use an h for hours or a t for time, whatever you want to use there. Hey, we've got a little equation. Let's combine these. So if I made this a common denominator, 12, right? So I do 3/3 and 4/4. So I get 3/12 plus 4/12 equals 1 over t. So 7/12 equals 1 over t. Now you can just flip them, or you can cross multiply if you want. So t would equal 12/7 of an hour. And again, you could write that as a decimal if you wanted, but about 12/7 of an hour. Okay?